Hey guys, it's Mrs. Page. I wanted to share with you today an engineering design challenge. You probably have the materials you need already at home, and we're going to follow the steps of the engineering design process and create our very own straw rockets. So the first step in the engineering design process is to ask a question or state a problem that you want to solve. So our question for today is, how can I make a straw rocket that will fly the furthest distance? So for this challenge, our criteria is to design and build a straw rocket that flies the furthest distance. The constraints, or the things that we really have to work within and consider, are that we're only going to be able to use the listed materials and that we are going to have to test in an environment with limited wind, because that can really impact the results of your flights. So the materials that you will need for this challenge: a straw, and everyone that's going to build a rocket really should have their own straw because you're going to be blowing into it. 2 pieces of paper, you might only need 1 depending on the design of your rocket. Some tape, you can use Scotch tape, you can use masking tape, you can use duct tape. Some scissors, and a measuring tool. So for the measuring tool, you could use a ruler, you could use a measuring tape, you could use like a fabric measuring tape, and if you don't have a measurement tool in your home, you can always use different ways to measure the distance of your flight and to compare the distances of your flight. So we'll talk a little bit more about that when we go and we test our first rockets. So the next step in the engineering design process is to imagine. So in the imagine stage, we want to think about, what is our rocket going to look like? How am I going to build it? And what materials am I actually going to need from that list? How much of everything am I going to need? So I'm going to take some time. I'm going to think for a few minutes about what I want my rocket to look like. And then I'm going to start drawing. And I've already done my imagine phase, so I'm going to show it to you. So my straw rocket, and my first idea for a straw rocket is just really simple. Just make a cylinder out of the paper, wrap it around the straw, fold it over at the end, and give it a little bit of weight on the tip. I do have some other ideas though. I'm not just sure that I'm going to use them for my first design, but they are going to be in the back of my mind, especially for my redesign phase. And that is, should I put some wings on the rocket? Maybe I could use like triangular wings. Should I have like a rocket or tip, like a cone on the front of my rocket? Would that help it fly, like cut through the air a little bit better? So I'm going to keep those ideas in the back of my head for my redesign. Then the third step of the engineering design process is to really get a plan going. So I've determined my design. I have my materials out and ready. I'm going to construct my rocket, then I'll choose a test space, and then I'll test, I'll redesign, and I'll share with you the results. So the next step in the engineering design process is the create stage. And this one is usually the most fun, because this is where you're actually going to use your ideas and your diagram to build your rocket. Now keep in mind that this is just your first prototype, your first rocket. So we're never going to be afraid of failure, because that is really where we learn, and we learn what we need to do better so that we can improve on our redesign. So for my create stage, all I need is, I'm going to use a small piece of paper. I have my straw, okay, so this is going to be my mouth straw. It's going to be my launcher. I have some Scotch tape, and I have a pair of scissors. So I have already cut out my paper that I'm going to actually make my rocket out of, and I am going to make a cylinder with the paper by wrapping it around the straw. And then I'm going to tape it so that it stays in that shape. Then what I did is I folded the end over, folded the end of my paper over, and I just taped it down. So it kind of gives my rocket a little point at the front of it. Okay? So this is actually going to be my first design, right? My first design idea. It's really simple. I'm going to test it out and I'm going to see how it works. So for your test, you are going to choose a testing space. So I'm going to be testing mine in the hallway in my kitchen because it's a really windy day outside. So if it's a nice day outside, you could always do it in your backyard or you could do it in your driveway. Keep in mind social distancing, being safe. But for today, I'm going to do it indoors. And I'm going to make sure that I have a starting line marked so that I'm always starting my tests from the same spot so that I can get an accurate measure of distance. I'm going to do 4 to 10 trials of my first design. So I'm going to take my straw rocket and I am going to launch it anywhere between 4, 5, 10 times, and I'm going to measure each distance of the flight, and then I'm going to record my data and I'm going to see which is my furthest flight. So before we do our test, I'm just going to show you how I'm going to kind of collect my data. And I only use a small piece of paper. You could collect your data on any kind of paper. Don't have to have a fancy table, but you can see that for my first design, design 1, I'm going to do 4 different launches, 4 different trials, and I'm going to measure the flight distance for each, and then I'm going to record it in my data table so that I can determine what was my longest flight for my first design. All right, guys, so I'm going to start my tests, my flight tests, and I'm going to show you how to launch your rocket. So you just put your straw, the rocket around it, and then you're going to make sure that you have your starting line set up. So I'll show you mine in a minute, but I put just a piece of tape on the floor so that I know exactly where I start from every time. So that'll be important when that's where you're going to measure from to see how far your rocket went. Okay, so here we go. Test number 1. Ooh, it hit the wall, but the next thing I'm going to do is I am going to take my tape measure. And again, if you don't have like a tape measure, you can use a ruler, or I can give you some other ideas for how to measure the distance. And you're going to measure from your starting line on the floor all the way to where the rocket landed. And you're going to measure to the nearest inch. All right, so I wanted you guys to see how I measured the distance of my flight to the nearest inch. It's a little tricky to show you on camera, but if you just kind of bear with me. So we have our starting line, that blue tape, and I measured right from the edge of that starting line all the way to the tip of my rocket, and it was actually 7 feet 6 inches. So I am going to take my data table and I am going to record how far my first flight was to the nearest inch. So my data table for my design 1, my first trial, 7 feet 6 inches. I'm going to do 3 more trials and we will see what the furthest distance I get is. And if you don't have a measuring tool, a tape measure, or a ruler, you can always take small pieces of paper or small pieces of tape, and on the floor you can just mark where your flight went to. That way you can compare your trials and you can at least see which trial was the furthest. One way that you could measure is you could use something like your hand. So if you think about the size of your hand, my measuring tool. So my hand is about, from here to the tip of my finger, 6 inches or a half a foot. So if you use your hand, you think, oh, my hand's about the same size as Mrs. Page, that would be 6 inches per hand. Or you could, if your hand's a little bit smaller, maybe you go with it's about 5 inches and you can measure the distance your rocket flew using your hand, kind of like an estimation for your measurement. All right, so I did my 4 trials and I had 7 feet 6 inches, 11 feet 6 inches, 10 feet 2 inches, and 7 feet 1 inch for my 3 flight distances. So I put a star next to my longest flight. It was 11.5 feet, or 11 feet and 6 inches. And I was really excited about that one. I thought it was awesome. And on that one, I did notice that it didn't hit the wall. So it went straight down the hallway, and I think that just let it go for the furthest distance. So the last step in the design process, before you kind of really share your results, your official results, and you evaluate your designs, is to improve. So based on the results of our trials, we're going to try redesigning our rocket and retesting it to see if we can get some further distance, or a distance that's further than 11 feet 6 inches. So I'm going to go back to my imagine stage and really think about those additional components that I thought about for what could make my rocket better. And I had talked about making a little cone tip for it, and also putting some like triangular wings on the back of it. So again, all you need, you just have your paper. And for my redesign, I cut out two little triangle pieces of paper, and I have a smaller piece that I am going to make into like a cone to go on the front of my rocket. And then I'm going to keep my circular cylinder that was the original body of the rocket. So I have put together my second redesign, and I have to say this one is much fancier looking, a little bit sleeker looking, but I'm not sure if it will work better. I was thinking it might, because I thought the point on the front might help it kind of cut through the air a little bit more efficiently. And then I thought, oh, maybe the little wings would help it kind of help it float a little bit. So I'm going to take this and I'm going to test it out again in the same conditions where I tested my first rocket. So I'm going to do it in the same place. I'm going to have the same starting line. I'm going to use the same measurement tool so that my data is accurate and I can see which design works the best. All right, so here I am with my second straw rocket, my redesign, and I am going to test this one. I'm going to do another 4 trials to see the furthest distance that I can get. Ooh, not bad, but it did do a little spinny thing. Maybe that has to do with the little propellers I put on the back of it. So now I'm going to get my measuring tool. I'm going to measure the distance of that flight, and then I'm going to do that 3 more times. All right, so I've tested my redesign and I have my result. So for my second design, I had 4 trials again. The first one was 9 feet 8 inches, 9 feet 10 inches, 7 feet 4 inches, and 10 feet 1 inch. So for my redesign, my furthest flight was actually 10 feet 1 inch, which is a lot shorter than my furthest flight with my original design. So that tells me my original design was a little bit more effective in reaching my goal for this design challenge. If I was going to redesign again, I might think about taking those propellers off of the back and just trying it with the cone tip, because on my trials for my second design, I noticed that it was spinning a lot, and I think that had to do with the propellers on the back. So that is me sharing with you the results of my engineering design challenge, and my first rocket was the winner, the very simple one, right? Not as fancy looking, but more effective for the job. So I hope you can give this a try at home. You don't have to do all the data collection and the measurement if you don't want. You can always just use these materials and design a straw rocket for fun. I know that Rocco had a lot of fun using the straw rocket that he built. So I hope that you can find some time to try out this engineering design challenge. And remember, don't be afraid of failure. All right, be well. I will see you hopefully soon. Bye.